Hello viewers, welcome back to my channel. This is the simplest video lesson you ever come across on how to determine the resultant of more than two vectors acting at a point. So if you are new to this channel or you came across this video for the very first time or you have been watching other videos on this platform but you haven't subscribed to this channel, do it to click on the like and subscription icon and also turn on the notification bell so that whenever I release any video, you will always get notified. So in the course of this video lesson, I'm going to teach you simple and practical steps on how to determine or calculate the resultant of more than two vectors acting at a point. In our previous video lesson, we looked at the case of two vectors acting parallel to one another, either in the same direction or opposite direction. We also look at the case of two vectors acting perpendicular, which is at right angle to one another. And then we looked at the case of two vectors acting at angles but not 90 degrees, where we say that we apply what we call the parallelogram's law of vector addition. But in the course of this video lesson, we are going to look at more than two vectors acting at a point. Now, this type of or this aspect of vector addition gives students worry because we have more than two vectors and they find it hard knowing which angles to use and how to even resolve this question. But in the course of this video lesson, I'm going to teach you simple and practical steps that will help you to resolve any number of vectors, be it 5 vectors, 10 vectors, or even more than that. So do it to get your writing materials and let's get started. So in resolving more than one vector, in this case, we have this vector here, F1, we have this vector here, F2, we have this third vector, F3, and then we have this fourth vector, F4. So they have their respective angle. For F1, the angle between F1 and this positive x-axis is theta 1. The angle between F2 and the positive x-axis is theta 2. Similarly, the angle between F3 and the negative x-axis is theta 3. And also, the angle between F4 and the negative x-axis is theta 4. So remember, on a graph, we have 4 cardinal points. We have this positive x, we have this negative y-axis, we have this positive x-axis, and then we have the negative x-axis. So let's look at how we can resolve more than two vectors acting at a point. So this is a simplified step to determine the resultant of more than two vectors. Now, the first thing you have to do is that you have to make the positive x, now emphasis on this part, the positive x, the reference point. And reference means where we make all our calculations from. But in this case, it is where we are going to measure all our angles from. So the positive x is our reference point and we are going to take it as 0 degree. And all angles are going to be measured from this positive x-axis. So we are going to measure all angles from the positive x-axis. So the second thing you do is that you have to measure all the angles in an anticlockwise direction from that positive x-axis. So I'm going to show you this in the next slide. So we are going to measure all the angle in an anti-clockwise. Anti-clockwise means in the anti means against or opposite. Then clockwise means the normal way the hands of the clock move. Now the hand of the clock move like this. It goes like this. But then anti-clockwise is in the opposite direction, meaning we are going like this. So in the reverse direction. Third thing is that we use sine for the y-axis. And then I'm going to show you where we do that. And then we use cosine for the x-axis. I'm going to show you how we do that. So in this section, I'm going to explain the various steps on how to determine the resultant of more than two vectors acting at a point using this diagram. So in this case, we have 5 vectors. We have F1, we have F2, we have F3, we have F4, and finally, we have F5. Now in the steps, the first thing is that we have to make the positive x-axis the reference point. So the positive x-axis is the side on the east or the side on the right hand. So just this side, just this particular side is the positive x-axis. And remember, the positive x-axis is at 0 degree because we have to measure all angles from this positive x-axis. So the first vector we have here is F1. So F1 is lying on the positive x-axis, meaning the angle it is making is 0 degree. So the angle of F1 to the positive x-axis is 0 degree. So the next vector we have is F2. Now for F2, the angle from this positive x-axis in an anti-clockwise, anti means you are going in this direction against the clock direction. because the clock goes like this. But in this case, we are moving in the reverse direction. That's like this. So from the positive x-axis to F2 is 60 degrees. So the angle F2 makes is 60 degrees. So similarly, from the positive x-axis now to F3, we know that this angle is 90 degrees already. So F2 is making an angle of 90 degrees. Now for F4, remember, you are starting from the positive x-axis and then you are going to that vector. So from the positive x-axis to F4 is going to be, now remember, this is 90. So from here to here is 90. Then from this point to this point is 30. So 90 plus 30 will give us 120. So F4 is making an angle of 120 degrees to the positive x. Remember, you are going anti-clockwise. Don't ever attempt to go like this. This is wrong. So now we're also going to find the angle F5 mixed with the positive x-axis in an anti-clockwise, meaning we are going like this. We are going in this format. So from here to here is 90. Then from here to here is another 90, giving us 180. Then 180 plus another 90 to get to F5 is 270. So the angle F5 make with the positive x-axis in an anti-clockwise is 270. So it is these angles we are going to use to solve. So with this, you don't have to start thinking which is positive and which is negative. So the third thing we talked about is that we use sine for the y component and then cosine for the x component. And then you might be wondering why. Now it is simple stuff. Now Fy is facing this angle and the side facing the angle is referred to as the opposite. Then the longest side is referred to as the hypotenuse. Then the other side left is the adjacent. Now for opposite and hypotenuse, we use sine. So we know that sine is equal to opposite over the hypotenuse. So the sine of the angle, let's say, will be opposite, which is Fy, over hypotenuse, which is F. So when you cross multiply, Fy will be equals to F sine theta. So we use sine for the y. Then for the x, so this adjacent and then this hypotenuse. So based on trigonometry, we know that cosine is equal to adjacent over hypotenuse. So in this case, the cos of the angle or the cosine of the angle is adjacent, which is fx over f. So when we do the cross multiplication, fx will be equals to f cos theta. So one thing I just wanted to pick up from is that for your y component, you use sine, and then for the x component, you use cos. So let's use this in solving a question. So this is a modified JAM 2007 question 14. Now we have this particular diagram. We have 4 forces, 3 Newton right here, 10 Newton, 4 Newton, and then 6 Newton. Now the question reads, the figure above shows 4 forces, 3 Newton, 10 Newton, 4 Newton, and 6 Newton acting at a point. The resultant of their forces is, now we have various options, 10 Newton, 9.46 Newton, 5 Newton, and then 6.48 Newton. So now in doing that, remember we have 3 steps we are going to apply. So the first thing we have to do is that we are going to make the positive x-axis our reference point. And on the positive x-axis, we have a force here, which is 3 Newton. So 3 Newton is lying on the positive x-axis, meaning the angle here will be 0 degree. Now the next force we have is 10 Newton. Now the angle from the positive x to 10 Newton and anti-clockwise manner is 30 degree, which is already given. So this is 30 degree. So the next vector, the next force we have here is 4 Newton. So the angle from here to 4 Newton is 90 degree because that is at right angle. So that's 90 degree. Then the last vector we have is 6 Newton. So the angle from this positive x to here is 90. Then to this point is 180. Then 180 plus 60, which we have here, is 240. So this is 240. So in solving, we just need the forces and then the angle. So we just simply have something like this. So we have the forces and then the angles they make with the positive x-axis. So for 3 Newton, with what you can see, the angle it makes with the positive is 0 degree. Then for 10 Newton, it's 30 degree. Then for 4 Newton is 90 degree. And then for 6 Newton, it is 240 degrees. So we are going to use this in solving. So here's a table which shows us the various forces and the angles to the positive x-axis, which we got from the diagram. So in resolving, remember the third step says that we use sine for the y component and then we use cosine for the x component. So what we are simply going to do is that for the fx, let's start with the x component. For the fx, we are going to pair each of them with the angle. So it's going to be 3 cos 0 because this is the x component. So we are going to have it as 3 cos 0 degree plus 10 cos 30 degree. So 10 cos 30 degree plus the next we have there is 4 cos 90 degree plus the last we have there is 6 cos 240 degree. So we are just simply going to pair each of the forces with the angle using cos for the x component. So now when you take your calculator and then you press all these values into it, you're going to end up having 8.66 Newton. Now for the Fy, we are going to change this cos to sine because for the y we use sine. So this is going to be 3 sine 0, no longer cos. It's going to be 3 sine 0 plus this is going to be a 10 sine 30. Then we have next to be 4 sine 90 plus the last will be a 6 sine 240 degree. So we have all of this. So when you take your calculator again and then you press these entire values into it, you're going to have 3.80 Newton. So this is the simplest thing you can ever do. So now there's something I just want to let you know. Now in this case, our fx is 8.66 and then our fy is 3.80. So I'm going to show you how we are going to use these values to get our final answer. So from our calculation, fx is 8.66 Newton and fy is 3.80 Newton. So if you take a close look at fx and fy, you find out that they are both positive. So this is positive 8.66 and then this is positive 3.80 Newton. Now remember on a graph, you have the positive y and you have the negative y. Similarly, you have the positive x on this side and then you have the negative x. Now since fx is positive, we are going to draw it towards this side. And then since fy is positive, we are also going to draw it towards the positive y. So we are going to have this fy, this 3.80 Newton, and then this is our fx. Our fx in this case is 8.66 Newton. So there are cases where you can have them to be negative. So where you have them to be negative, you draw them towards the negative side. Let's say, for example, let me take you. So let's say we have fy to be a positive 2, and then we have fx to be a negative 4. So in this case, we are going to have something like this. Fy is positive, so we are going to draw it towards the positive side, and then just add 2, let's say for this example. And then fx is negative, so we are going to draw it towards the negative side, and then write 4. Now the minus or the plus tells you direction, but you are not going to use it to solve anything. So it just tells you direction. Positive means it's going to the positive side, and then negative means it's going to the negative side. So the value is just the same value. So let's say we have another one. Let's say we have fx to be negative 8, and then we have fy to be negative 10. So similarly, it tells us that the x is acting towards the negative x-axis, which is this way, and then y is acting towards the negative y, which is this way. But then fx will be 8, and then fy will be 10. So coming back, the sign just tells you direction, but it's never used in solving. So now let's go on and calculate the final resultant. So the resultant will be something like this. So let's close this up, and then this is our resultant. Remember, when we have vectors like this, you simply apply Pythagoras theorem because at every point it is 90, 90, 90, 90. So we are going to apply the Pythagoras theorem, which is hypotenuse square is equal to opposite square plus adjacent square. So if this side is 3.80, this side will also be 3.80, 3.8. So now the hypotenuse is the resultant. That's the resultant square is equal to opposite. Let's take it as 3.8 square plus the adjacent, which is 8.66 square. So now arrow square will be equals to, now when you solve this, you are going to end up having 89.44. So then you take this square to this side and then it becomes a square root. So I'm going to have that as r is equal to the square root of 89.44. So when you simplify that, r will give you a 9.46 Newton. So our answer to the question is 9.46, making the answer to be option B, which is a 9.46 Newton. Additionally, you can also calculate the angle to which the resultant is acting, because in every vector, it is calculated both in magnitude and then in direction. So the direction will be from here to this positive x-axis. So this is the direction, theta. So now how do you calculate direction? If you go back to our previous video, we say it's calculated using tan inverse of the resultant in the y. So in this case, let's say if it is fy over fx. So the vector acting in the y over the vector acting in the x. So theta will be equals to tan inverse of the vector acting in the y-axis is 3.8. That's a 3.8 over a vector acting in the x-axis, which is an 8.66. So when you divide that, so theta will be tan inverse of 0.44. So when you take the tan inverse, you are going to have 23.7 degree. So this is the direction. So therefore, in magnitude, it is 9.46 Newton, and then direction is 23.7 degree to the positive x-axis. Very important, to the positive x-axis. So we have it in magnitude and then in direction. So viewers, that brings us to the end of this video lesson. Do it to click on the like button and also share this video lesson with your friends so that we can all learn together. And if you haven't subscribed to this channel, do it to click on the subscription icon and also turn on the notification bell so that whenever I release a new video, you will always get notified. Till you get to see my next video, do have a wonderful time.